Hi, I'm back and I'm going to be talking about the book Physics of the Future by Mr. Kaku again. So, yeah, um, I've previously done Chapter 1, Future of the Computers, Chapter 9, A Day in the Life of the Year 2100, and Chapter 2, The Future of AI. Today I'm going to be doing Chapter 6, The Future of Space Travels. The Future of Space Travel, which is on page 255. So I'm just going to flip through that real quick. And the quote for the chapter is, "We have lingered long enough on the shores of the cosmic ocean. We are ready at last to set sail for the stars." Carl Sagan was the one that said that. And I'll be reading one section from this chapter. In powerful chariots, the gods of mythology roamed across the heavenly fields of Mount Olympus. On powerful Viking ships, the Norse gods sailed across the cosmic seas to Asgard. Similarly, by 2100, humanity will be in the brink of a new era of space exploration, reaching for the stars. The stars at night, which seem so tantalizingly close, yet so far, will be in sharp focus for rocket scientists by the end of the century. But the road to building starships will be a rocky one. Humanity is like someone who outstretched arms are reaching for the stars, but whose feet are mired in the mud. On one hand, this century will see a new era for robotic space exploration as we send satellites to locate Earth-like twins in space, explore the moons of Jupiter, and even take baby pictures of the moon itself. However, the manned exploration of outer space, which has enthralled many generations of dreamers and visionaries, will be a source of some disappointment. And so basically this chapter talks about the types of space travel we could possibly use and what we would have to overcome. And so there are a few main factors of space travel that we have to overcome. There is the cost, where they're going to get the money from, the weight. The heavier it is, the slower it'll be, and it will run out of fuel quicker. The crew, how many people you'll be able to fit on it, how many people you're going to be needing on it, who's willing to sign up, what are you going to send to space. Time, how long it'll take. Let's say if you want to go somewhere, it'll take like 100, 200 years. How are you going to keep someone, how are they still going to be alive? That also comes with the weight. You have to have food for them. And you have to have food for them, which is weight, and food also costs money, and so that goes to the cost. The distance also applies to time. The further it is, the longer it'll take to get there, which also applies to weight and cost. Safety, what safety measures do you have to take, which applies to cost and weight. The plan and the calculations. If you get like one calculation wrong, then the whole ship crashes. You'd have to take millions and billions of calculations if you want to go to space. And so you get one wrong, one screws up, then you're screwed. And so how to overcome these? Cost. Let's say you can have other companies sponsor you, you can have the government sponsor you to get money. That's one way to get money. Weight. You can reduce weight by using lighter materials and reducing the portion of everything you have on the ship. Crew. I don't know, like, how to overcome. Well, you just tell if not many people are willing to sign up for to go on it, the ship, to go hundreds, thousands, millions of miles away from their home, and a lot of people aren't willing to do that. For me, take me for instance, I wouldn't be willing to do that. You can't really change how they feel about it unless you tell them all the good stuff about it and stuff. Time, how long it'll take to get there. Well, let's say it'll take 300 years to get to the star you want to get to. You would obviously be dead by the year in 300 years. But so you could scientists are thinking if you can freeze a body and preserve it, and kind of set a timer on it. So say after 250 years, just have them wake up with the body perfectly fine, same age as you left them with. Distance. You can cover distance applies to time. The longer it is the longer it takes to get there. You can have faster rockets and stuff. Safety. Just find all the things that can possibly harm you or to, cause the mission to stop, and you can try to overcome it. The calculations. You don't have to have humans and people have to do calculations and everything. You can depend more on electronics and like computers and stuff because they're generally more accurate. And so I'm about the 5. But right now, if you want to go to Mars or something, our rockets are currently way too slow. The fastest rocket has covered only 1/600th of a light year. 1/600th of a light year. Over the course of 30 years. That'll take that so it'll take 80,000 years to get to the nearest star, which is Alpha Centauri. So I'm going to talk about the 5 fastest methods of space travel. Number 1 would be a solar sail. The idea was created in 1610 by a scientist named Johannes Kepler. And basically, scientists have already put 2 solar sails into space. Basically, you launch a spaceship into space, and then you deploy the sails. And when the solar beams of the sun, when they hit the sail, they'll bounce back, but they also push the sail a bit faster each time. And since the space is a giant vacuum, there's no air, there's nothing stopping it, there's no gravity, there's no force stopping it. So it'll keep going until it hits something like an asteroid. But the sun's sails will keep smashing against the sail. It'll keep accelerating. And sooner or later, scientists say, you can almost reach the speed of light because you'll keep going faster and faster. But of course, you couldn't reach the speed of light because if you want to be as fast as the speed of light, you would have to have no mass. And so, of course, spaceships have mass, so you can't go to the speed of light. But in Star Wars, they have something called hyperspeed, which is a lot faster than the speed of light. And basically what it does is it manipulates wormholes, so it can make a wormhole wherever it decides to, and that's how it just gets from place to place. And that's number 2 on our list. So I'm going to get a piece of paper and explain to you how a wormhole works. Basically, space travel, the point of it is to get from point A to point B. And so here it is. But you don't want to travel that entire distance. And so what a wormhole is, string theory, you probably already know it. So you put a big enough of a force in the middle, like a supermassive black hole, or something that has a lot of energy, and you bend space-time itself. And so instead of having to travel the distance, you have that distance come to you, if you know what I'm trying to talk about. So you fold it, and instead of having to go the whole thing, distance, you just go that tiny distance right here. So a tiny distance, and that's basically how wormholes go. And wormholes can reach very close to the speed of light, not faster. Number 3 on our list would be ion thrusters. And basically ion thrusters, they smash electrons into ions, and basically it causes the already unstable positive ions to receive the electron so fast that it becomes unstable, and it goes out of the spaceship, and it pushes the spaceship this way while the ions come out this way. but scientists say it's too uncontrollable, so it might like destroy a spaceship. Well, you can manipulate ions through an electric field, so you can create your own electric field around the thruster, so that you can control it and it won't destroy the spaceship. So, and last, certainly not least, we have the M drive. So the M drive is the most interesting. They're still debating about it because it legit breaks physics. It kind of breaks laws of physics. And so, solar power, they use solar beams. The spaceship creates its own solar beams. Solar beams slowly deteriorate into something called microwaves. And microwaves, they look kind of like this. And those waves are called resonant kite thrusters. Those resonant kite thrusters, that's what the wave is called. When they bounce into something and they hit something, anything, in this case it would be dark matter, dark energy, the larger force is on the wider side of the wave, pushing the engine. So it gets faster and faster. And so no one really gets how this works except for the person who created it. They're still debating about it because it technically breaks the laws of physics. And so manipulating this is called the Unhull radiation. Don't ask me why Einstein decided to name it that, because Einstein's the one who founded that. And so yeah. And it hasn't been looked into really far yet because people still think it's kind of insane. And so those are the 4 fastest ways to travel through space. But the 4 ways scientists are actually think are possible are, let's see. Are nuclear rockets, ramjet fusion, antimatter rockets, nanoships, and I think that's it. So basically, nuclear rockets are basically, scientists are considered using nuclear energy, to be more specific, nuclear fusion. Basically, when you combine nuclear fusion, you're combining stuff. Fission is when you split apart stuff. Fission, we're using fission in nuclear power plants right now because it's more sane and we know how to use it better. But fusion is a lot more powerful. It's just that we don't know how to use it very well yet. And so you would smash stuff into each other. You would have a kind of mini particle accelerator in your rocket. You'd smash stuff together, and they would combine, or they would split apart. Right? They would split into a million pieces. But most likely, they would just combine. And that energy it creates when it combines is immense. And so you direct it using a magnetic field into one direction, pushing the rocket the other direction. The other is a ramjet fusion rocket. Ramjet fusion is similar to an ordinary jet fusion, but it's a lot faster. And it's a chemical explosion, so it's kind of like this. It's basically a plasma rocket. It's hard to explain. Plasma is something really, really hot, and it's considered, there are 3 states of matter: liquid, gas. Well, we learned that in school there are 3 states of matter: liquid, gas, and solid. But they say that plasma is a 4th state of matter because it's that hot. So it basically works the same as a ion thruster. It has positive ions, and it smashes particles into them, directing them out the other way. But they're so unstable, they vibrate so much, they create heat. So that heat has a lot of energy. So yeah, the energy goes out one direction, and the rocket It was the other direction because every reaction has an equal and opposite reaction. So yeah, antimatter rockets. Antimatter is like matter, but everything is reversed. Everything has a different role. So when antimatter meets matter, it explodes. The most expensive thing ever created on Earth is 1 gram of antimatter. And they spent billions of dollars trying to make 1 gram of antimatter. But they controlled it. Nothing exploded. They controlled it through a magnetic field. And so they're trying to control it to blast it out one side of the rocket. And so, every reaction has equal and opposite reaction. So it goes out the other way. So that's how it's going to be really powerful, really unstable. It's going to be really unstable too. It's going to cost lots of money. So this is one of they're not looking too forward to, but it's one of the most I don't know how to say this, but it's like one of the most ways scientists are actually thinking about, they're looking forward to, that they might actually use it. Nanoships. So nanoships uses nanotechnologies. Scientists don't really think they can actually create nanoships, but this is how they work. They have nanoparticles, and they would heat them up. They'd become gases. They'd fire them out one direction, and the ship would go the other direction. So it's kind of basically all these ships will work the same. Every reaction is an equal and opposite reaction, and so yeah. Scientists are also looking to terraform Mars. Since Mars has a different gravity than us, as you saw in the movie Man of Steel, they would terraform Earth because the Kryptonians, the planet got destroyed, but on Earth they have a different gravity than they do on Krypton, and so they try to change the gravity of Earth, but that would kill everyone else. That would kill everyone, all the humans on Earth and everything that lives on Earth. And so we can terraform Mars. Scientists don't know how, but they're trying to find a way to basically change Mars's gravity to the same gravity as ours. Another way to travel into space is space elevators. And so space elevators are interesting. And yeah, they think they can be used around the year 2070 to the year 2100. And so space elevators are very interesting because think about an elevator that can go to space. You would think about many things, like how long would it take to get there? Elevators, the Burj Khalifa is the tallest building in the world. It takes 13 minutes to get from the bottom to the highest floor. That's 279 floors. But that's not nearly as far as from Earth to the moon. That's not nearly as far. It's not even a mile long or a kilometer long. So that's one thing. You don't want to just live in an elevator or just stay in an elevator for months or a year. So and the second thing is, where would you get the energy to power the space elevator? They're thinking about using solar power. That's basically like they would put solar panels on the elevator, directly on the elevator, and it would receive energy from the sun, and that's where it'd get the energy. Another thing is they would need the lines for the elevators. They would need to the strongest material we know right now is carbon nanotubes, but it would have to be extremely long, and the longest we've ever made was 2.5 meters. So yeah, we're probably not gonna have a space elevator for quite a long time. And so those are the methods of space travel and how they work and everything. Okay, I'm gonna see you guys tomorrow. Bye.